Hello, pre-calc students. Doing a walkthrough for our practice tests on My Open Math. So we're going to start with polynomials. And so the first problem is we need to find the end behavior of this following graph. So as x approaches negative infinity, so that means we have our x value, our x-axis approaching negative infinity. What is our y? What is happening to our f of x value? So this is our x-axis. This is our y or f of x axis. What's happening to our f of x function? Well, f of x is approaching positive infinity. So f of x will be approaching positive infinity. As x is approaching negative infinity, f of x is approaching positive infinity. As x is approaching positive infinity, what's happening to our f of x function? What's happening to our f of x value? Well, f of x is going down, 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 down. That is approaching negative infinity. So we are approaching negative infinity. So the answer here is that as x approaches negative infinity, f of x is approaching positive infinity. As x approaches positive infinity, f of x approaches negative infinity. As x gets larger from left to right, our y value becomes a very large negative number. And as x gets smaller, moving to the left side of the graph, our y value gets larger, approaching infinity. Okay, so we're going to hit the submit button. So I'm going to clear annotations. Hit the submit. Okay. Possible for us to submit here. Negative infinity, 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 negative infinity. Hit the submit button. Okay, here we go. We're allowed to submit here. All right. We need to calculate the following values of the piecewise function. H of -1. Well, -1 is, so we have to figure out whether we're formula 1, 2, or 3. -1 is less than or equal to -1. So this is formula 2. Because -1 is less than or equal to -1. It's not less than -1. It's not greater than or equal to 5. So we have 4 times -1 squared plus -1 minus 7. So that's going to be equal to -1 squared is 1. So that's 4 minus 1 minus 7. So that's going to be equal to 3 minus 7. So that's going to be equal to -4. -4 is in this category. It is the first formula. So we have -4 minus 10. So that's equal to +4 minus 10, and that's equal to -6. -5 is also less than -1. So we use the first formula. -5 minus 10 is equal to 5 minus 10, which is equal to -5. Ten is greater than 5, so that's going to use formula number 3. And so we plug in -2 times 10 plus 3, so that's equal to -20 plus 3, and that's equal to -17. H of 5, well, 5 is greater than or equal to 5, so that's going to be formula number 3. And we plug in 5 into formula number 3. -2 times 5 plus 3 is -10 plus 3 is equal to -7. H of 1. 1 is greater than -1, less than 5, so that's going to be function number 2. And we'll have 4 times 1 squared plus 1 minus 7, so that will be equal to 4 plus 1 minus 7, so that's equal to 5 minus 7, which is equal to -2. I'm going to hit enter, submit. All those are right, clear annotations. Let's go to question 3. All right. We have 7. Our parent function right here is just 7 to the x. 7 to the x, so that's our parent function. And let's analyze our transformations. We have a minus sign right here, that's an x-axis reflection. So let's actually have an x-axis reflection. We have 4/5 is outside the function, so that's going to be, 4/5 is a fraction less than 1, so that's a 4/5 vertical shrink. Remember, it was inside the function, would be horizontal, but this is 4/5 is outside the function. Vertical shrink. We have 7 of x plus 6. So we switch our sign. We don't need to factor out because x doesn't have a coefficient. So it's going to be left 6 left 6. So we have move 6 to the left. So that's horizontal. And then that minus 7 is outside the function. So that's going to be down 7. So we've identified all our transformations. Let's go down. Our reflection, we have a reflection across the x-axis, a vertical compression by 4/5, vertical shift down 7, and a horizontal shift left 6. Let's submit. All right, all those were right. Question 4. Find the inverse function. We have to switch x and y. X is equal to 2y plus 2 over 3y minus 1. Multiply each side by 3 minus y minus 1. Multiply this side by 3y minus 1. Multiply this side by 3y minus 1. Distribute the x. We will have 3xy minus x. 3y minus 1's cancel out. Is equal to 2y plus 2. Now I got to get all my y's on one side of the equation. So listen to my voice. I add x to each side and I subtract 2y from each side. So now I have 3xy minus 2y is equal to positive x plus 2. Now I need to get a y by itself, so I factor out a y. What's left over is 3x minus 2 is equal to x plus 2. And I now divide each side by 3x minus 2. So I can cancel out and isolate my y. So my y is equal to x plus 2 over 3x minus 2. And now that I've isolated y, I have found my inverse function. The inverse of the function is equal to x plus 2 over 3x minus 2. So I'm going to know that inverse function is equal to x plus 2 over 3x minus 2. Hit the save button. I'm going to submit that. 1 and a 1, got it right. That's excellent. Let's go to question 5. So you need to find the quotient remainder using long division. So let's break out our long division. We have negative 10x to the 4th plus 4x cubed plus 23x squared minus 9x plus 5, and we are dividing by 2x squared minus 5. So what do? I come up with that. I divide my leading term. So this is my leading term for my numerator, and this is the leading term for the denominator. And I always divide the numerator leading term by the denominator leading term to find my quotient. So here, negative 10x to the fourth divided by 2x squared, that's going to be 5x squared. What I'm doing is I'm picking the value. That's negative 5x squared. I'm picking the value that when multiplied by my leading coefficient is going to cancel out the leading coefficient of the numerator. So negative 5x squared times 2x squared is negative 10x squared. And negative 5x squared times negative 5 is positive 25x squared. I take parentheses, I subtract negative 10x to the fourth, and sorry, negative 5x squared times 2x squared is negative 10x to the fourth. Negative 10x to the fourth minus negative 10x to the fourth. Two negatives make a positive, so that's negative 10x to the fourth plus 10x to the fourth. That's going to be 0. 4x squared minus 0, I just bring down that 4x squared. Sorry, 4x cubed minus 0, I bring down that 4x cubed. 3x squared minus positive 25x squared is going to be minus 2x squared minus 9x plus 5. Bring it all down. Now, to get the x cubed term, 2x squared times what equals 4x cubed? That's going to be 2x. So 5x squared plus 2x. 2x times 2x squared is going to be 4x cubed. And then 2x times negative 5 is going to be negative 10x. Parentheses, subtract 4x cubed minus 4x cubed is 0. Bring down that negative 2x squared. And then negative 9x minus negative 10x is 9x, negative 9x plus 10x, which is going to be plus 1x plus 5. So now I have negative 2, hard to see, x squared. And I need a term that multiplies by 2x squared to get negative 2x squared, so I can cancel out. That term is going to be negative 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times negative 5 is positive 5. So what I'm doing is I subtract here. Negative 2x squared minus negative 2x squared. That's negative 2. That's two negatives make a positive. Negative 2x squared plus 2x squared is 0. 5 minus positive 5 is 0, and all that's left over is x. So this is my quotient. Negative 5x squared plus 2x minus 1. That is my quotient. And 2x squared can no longer go into x because x has a lower degree than 2x squared. Degree of 1, degree of 2. So because I can't no longer divide, this becomes my remainder. So my quotient is negative 5x squared plus 2x minus 1, and my remainder is x. Let's hit submit. 1 out of 1, all of that was correct. So that's the successful example of polynomial long division. Always pause if you need me to do that. I'm going to, let me clear the page. Can I delete that? How to make this go away? Close. Okay, sorry about that. So moving on, next question. Question 6. All right. So here, I can use the remainder theorem. So by the way, if I'm dividing by x plus 2, I can evaluate f of negative 2. So x plus 2, I find f of negative 2. X plus 1, that's f of negative 1. X, that's f of 0. X minus 1, that's f of positive 1. X minus 2, you just find x of positive 2 to find the remainder. If the remainder is 0, then that is a factor. Now, we do, so let's evaluate. Let's evaluate the first one. 3 times negative 2 squared minus 8 times negative 2 plus 3. So that's negative 2 squared is positive 4. So that's going to be 3 times positive 4. That's 12. 8 times negative 2 is negative 16. Minus negative 16 is plus 16. That's 12 plus 16 plus 3. All right, so 12 plus 16, that's going to be 26. 28, that's going to be 31. The remainder here is 31. So that's when x is negative 2. When x is negative 1, we have 3 times 1 squared minus 8 times 1. And sorry, and this is negative 1 times negative 1 squared times 8 times negative 1 plus 3. So this is negative 1 squared is 1. 1 times 3 is 3. 3 minus negative 8, that's 3 plus 8. So that's 3 plus 8. 3 plus 8 is 11. 11 plus 3 is 14. So our answer here is 14. When you're evaluating f of 0, you have 3 times 0 squared minus 8 times 0 plus 3. Well, anything times 0 is 0, so that's 0 minus 0 plus 3. That answer is 3. When your factor is x minus 1, we're evaluating f of 1. So that's 3 times 1 squared minus 8 times 1 plus 3. So that's 3 minus 8, that's negative 5, plus 3, that's negative 2. That's negative 5 plus 3, that's negative 2. And we're evaluating, dividing by x minus 2, we find f of 2. So that's going to be 3 times 2 squared, which is going to be 12, minus 8 times 2, so that's 12 minus 16, that's negative 4, plus 3, that's going to be negative 1. All right, so let's submit. All right, all those were right. We did that right. We successfully plugged in those values. So that is how we did question 6. Question 7. All right. Write the factored form of polynomial with the lead coefficient 1 and zeros of negative 2, negative 3, 2, and 3. So if we have a zero, so a leading coefficient of 1, which means that we just don't have any altering to our leading coefficient. We just keep that at 1, so we keep it as simple as possible. If you have a 0 of negative 2, your factor is x plus 2. If you have a 0 of negative 3, your factor is x plus 3. You have a 0 of 2, your factor is x minus 2. And if you have a 0 of 3, your factor is x minus 3. X plus 2, x minus 2, x plus 3, x minus 3. So this could be x squared minus 9 times x squared minus 4. Anyway, let's hit submit. 1 out of 1. Got it all correct. Excellent. So this is just simply knowing how to identify zeros and factors. Question 8. If f of x is a function which is continuous everywhere, then we must have b is equal to So in order to make a piecewise function continuous, the y values at the x value where the piecewise functions meet have to be equal to each other. So where do the functions meet? When x equals 6. And the y values need to be equal to each other when x equals 6. So if the y values need to be equal to each other, 3x minus 2 has to be equal to negative 7x plus b. So this is when x is equal to 6. We're going to plug in 6 for x. 3 times 6 minus 2 equals negative 7 times 6 plus b. So that's become 8. 6 times 3 is 18. 18 minus 2 equals, by the way, negative 7 times 6 is negative 42. Negative 42 plus b. So 16 is equal to negative 42 plus b. Add 42 to each side. Six plus 2 is 8. 1 plus 4 is 5. 58 is equal to b. So b is equal to 58. Let's see if I did my math right. That was correct. Let's keep going. Question 9. We need to just evaluate this, use this with polynomial long division. 2x cubed minus 6x squared plus 7x minus 13. And we're dividing by 2x squared plus 5. So 2x cubed multiplied by x. X times 2x cubed is 2x. So x times 2x squared is 2x cubed. X times 5 is 5x. Parentheses. Subtract 2x cubed minus 2x cubed is 0. Bring down that negative 6x squared. And then 7x minus positive 5x is going to be plus 2x minus 13. Now we have another x squared term. What times 2x squared is negative 6x squared? That's going to be negative 3, so we have x minus 3. Negative 3 times 2x squared is negative 6x squared. Negative 3 times 5 is negative 15. Parentheses, subtract. Negative 6x squared minus negative 6x squared is negative 6x squared plus 6x squared. Two negatives makes a positive. So there's negative 6x squared plus 6x squared is 0. Bring down that 2x plus 2x. Negative 13 minus negative 15 is going to be negative 13 plus 15, which is going to be just positive 2. That's going to be positive 2x plus 2. So that's going to be 2x plus 2. And that is a remainder because 2x plus 2 can no longer go into 2x squared plus 5 because 2x squared plus 5 has a higher degree, a degree of 2, than 2x plus 2, which has a degree of 1. So our quotient is x minus 3 plus our remainder, which is 2x plus 2, divided by our divisor, 2x squared plus 5. So we just need to put this into put this in our box. So I'm going to put in x minus 3 plus 2x plus 2 over 2x squared plus 5. And that should be in the form quotient plus remainder divided by divisor. Let's hit submit, see if we're right. We are right, so let's clear annotations and move on. Question 10. Rewrite negative 15x squared plus 24x plus 3 over 5x plus 2 in the form q of x plus r of x over 5x plus 2. So once again, we need to use polynomial long division, find our quotient, and find our remainder. So let's find the quotient. We're going to have negative 15x squared plus 24x plus 3, all divided by 5x plus 2, division sign. All right, so 5x times what equals negative 15x squared? That's going to be negative 3x. Negative 3 times 5 is negative 15. X times x is x squared, and negative 3x plus 2 is going to be negative 6x. Parentheses, subtract. Negative 15x squared minus negative 15x squared. 2 negatives makes a positive. That's negative 15x squared plus 15x squared. So that's going to cancel out to 0. And then we have 24x minus negative 6x. So that's 24x plus 6x. That's 24x plus 6x. That's going to be 30x plus 3. 30x plus 3. I can still cancel out 5x plus 2. My leading term is 5x. My leading term is 30. 5x times what equals 30x? That's going to be 5x times 6. Negative 3x plus 6. 6 times 5 is 30. And 6 times 5x is 30x. 6 times positive 2 is going to be positive 12. I take parentheses and I subtract. So 30x minus 30x is going to be 0, and 3 minus 12 is going to be negative 9. At this point, negative 9 cannot divide into 5x because negative 9 has a degree of 0, negative 9x to the 0, which is negative 9, as opposed to 5x to the 1, which is a degree of 1. So negative 9 is our remainder, and negative 3x plus 6, that is our quotient. So our quotient is negative 3x plus 6, and our remainder is negative 9. I'm going to hit submit and see if I made any math mistakes. I did not make any mistakes. Excellent. So you can always pause or go back to my other explanations if I'm moving too fast for you. Question 11. Rewrite negative 2x cubed plus x squared plus 13x plus 9 in the form x plus 2 times q of x plus r of x. So I just need to find the quotient and the remainder by doing polynomial long division. So I just need to divide negative 2x cubed plus x squared plus 13x plus 9 and divide this by x plus 2. All right, so I need a number that multiplies by x to give me negative 2x cubed. That's going to be negative 2x squared. Negative 2x squared times x is negative 2x cubed. And negative 2x squared times 2 is negative 4x squared. Parentheses. Subtract. Negative 2x cubed minus negative 2x cubed is negative 2x cubed plus 2x cubed. So that's going to be 0. X squared minus negative 4x squared is x squared plus 4x squared. So that's going to be 5x squared plus 13x plus 9. 5x squared plus 13x plus 9. Now, I have 5x squared plus 13x plus 9. And now you can cancel out that 5x squared. So if I have x plus 2, what times x equals 5x squared? That's just going to be plus 5x. So negative 2x squared plus 5x. 5x times x is 5x squared. 5x times 2 is plus 10x. Parentheses, subtract 5x squared minus 5x squared is 0. 13x minus 10x is going to be 3x plus 9. Now, I have 3x plus 9. To cancel out that 3x, I'm going to need negative 2x squared plus 5x plus 3. 3 times x is 3x, and 3 times 2 is 6. 3x plus 6. 3x minus 3x is 0. 9 minus 6 is 3. At this point, 3 is our remainder because 3 cannot divide into x because 3 is the degree 0, x is degree 1. And our quotient is negative 2x squared plus 5x plus 3. So let's put in our quotient. Negative 2x squared plus 5x plus 3. And I'm not feeling confident about putting it in this way, so I'm going to put it in where I'm more comfortable. Negative 2x squared plus 5x plus 3. And this is just going to be the remainder is 3. So if I did the algebra right, if I did my math right, this should be correct. I did get this correct because I did do the math right. So you can always check that work for to understand the process. All right, let's go to question 12. All right, we are increasing. So just look at my cursor, increasing on this interval and this interval. So we're increasing from 0 to 1 union 6 to off the screen infinity. So we're increasing from 0 to 1 union. Let me put in this the right way. Union and from 6 to infinity. Decreasing, the only time we're decreasing is look at my cursor from 4 to 6. So we're only decreasing from intervals 4 to 6. Never include the inflection points on increasing, decreasing constant intervals because at inflection points you're neither increasing or decreasing. You're at a special inflection point. Function is constant from negative infinity to 0 and from 1 to 4. So we are constant from negative infinity to 0 union and from 1 to 4. Okay, the domain, this function never doesn't have a domain. It goes on forever on the left, keeps on going on the graph, goes on forever to the right. So our domain is from negative infinity to positive infinity. And our range, our lowest y value is negative 8 because we stay at constant negative 8 forever. So our lowest y value is negative 8. We'll actually touch negative 8, so we are negative 8 inclusive. So we have negative 8 inclusive, and we move all the way up to infinity on forever as we approach our end behavior as x approaches infinity. So that goes from negative 8 to positive infinity. Hit submit. Right for all our questions. Let's move on to 13. All right. Find our real zeros and their factored form. So this is where we need Desmos. 6x cubed minus 31x squared plus 53x minus 30. 6x cubed minus 31x squared plus 53x minus 30. Okay, so let's find these real zeros. So it looks like all our real zeros are in this interval right here. So it's fine. We have a 0 at 1.50, 1.57, let's see, 6, let me make sure, 6x cubed minus 31x squared plus 53x minus 30, okay. 1.575, so it's actually, no, that's not a 0. 1.6660 and 20. So these are our zeros. 20, 1.6660, 1.50, okay? These are 3 zeros right here. 3 halves, all right, 1 2/3, and 2. So if we have a 0 of 1.5, I'm going to call it 3 halves. If we have a 0 of 3 halves, we have a factor of x minus 3 halves. I'm going to close this off for a second. We have a 0 of, this is 1.66666, that's going to be 1 2/3, or 5/3. We have a 0 of 5/3, we have a factor of x minus 5/3. And this view is kind of skewed up, so I'm going to change. I'm changing my y-axis so that my lowest y values are from -5 to 5. This helps me see it better. And if I have a 0 at 20, then I have a factor at x minus 2. And now I'm going to zoom in, see if we pass through at our zeros. So at 1.50, I do see that we pass through. At 1.666, I do see that we pass through. And at our 20, I do see we pass through. So we all have odd multiplicities at this point. If we bounce, which means when we hit our 0, we stayed above the x-axis instead of switching from above to below or below to above, that means we would not pass through. Anyways, we do have zeros of 3 halves, 5/3, and 2. So our real zeros are 3 halves, 5/3, and 2. All right, and now we need to find a factored form of this polynomial function. This is where we can really use Desmos to advantage. This is our function. And let's try adding coefficients so we can better match our function in the black. Because we have our factors. 2, let's multiply by 2. No. What about 3? Better. 4, closer. 5, closer. 6. What do you know? Multiplying by 6 times x minus 3 halves times x minus 5/3 times x minus 2 gives us the perfectly matching graph. This is our factored form. 6 times x minus 3 halves. 6 times x minus 3 halves times x minus 5/3 times x minus 2. And that is the factored form of the function. So let's hit submit. 1 out of 1, got it right. Question 14. We need to find f of g of x. All right. So we plug g of x into f of x. So this means this function goes inside that function. So we have 5 times 3x squared plus 4x plus 5. So 5 times 3x squared, that's 15x squared. 5 times 4x is 20x plus 5. So we have 15x squared plus 20x plus 5. Can't simplify it any further. This is equal to 15x squared plus 20x plus 5. 15x squared plus 20x plus 5 matches up. Hit submit. Got it right. Clear annotations and move on. Question 15. All right. We need to find our factors. Okay. Is x plus 5 a factor of x to the 5th minus 6x to the 4th plus 4x cubed minus 9x squared minus 4x plus 7580? The fastest trick I could do here is use the remainder theorem. If x plus 5 is my factor, I can evaluate f of negative 5. And f of negative 5 is going to be negative 5 to the 5th minus 6 times negative 5 to the 4th plus 4 times negative 5 cubed minus 9 times negative 5 squared minus 4 times negative 5 plus 7580. Let me quickly do this in my head. I'm just kidding, y'all. I'm not able to do this in my head. But what I can do is evaluate this in the calculator. So I have, let's turn Desmos into a new window. Clear annotations. Minimize this. Open back up the math assignment. Get it so I have multiple screens. Close out my previous functions, and now I have x to the 5th minus 6x to the 4th plus 4x cubed minus 9x squared minus 4x plus 7580. And if x plus 5 is a factor, that means we will have a 0 at negative 5, which we do. If our x value is negative 5, we have a y value of 0. So if our y value is 0, then the remainder is 0, and it is a factor. Now, let's go to 2x minus 3. If 2x minus 3 is our factor, if that's our factor, then that means 2x minus 3 is going to be a 0, which means that add 3 to each side. 2x would have to be equal to positive 3, and x would have to be equal to 3/2. So once again, if you want our x term, you could also just factor out the 2. 2 times x minus 3/2. And if x minus 3/2 is equal to a 0, then you're evaluating f of 3/2. Anyways, what I do is I clear this function. I need to find the value 16x to the 4th plus 72x cubed minus 4x squared plus 18x minus 342 All right, and then I'm going to find the value when x is equal to 3/2. Oh, that is 0. So the remainder is 0, and that is a factor. Now, my last function is x cubed plus 4x squared minus 2x minus 15. Look at my table. If x minus 3 is the factor, I'm evaluating f of positive 3. F of positive 3 is 42, and if your term is not a 0, when you set your factor equal to 0 and solve for x, if that value is not, x value does not output a 0, then that term is not a factor. So this is not a factor. So I've done my answer for all three. I'm going to hit submit. I am right on all of them. So that is excellent. Let's clear annotations and move on. Question 16. All right. If I have a 0 of 0, my 0 is x. If I have a 0 of 2, my factor is x minus 2. If I have a 0 of negative 7, my factor is x plus 7. I simply just need to put this in. X times x minus 2 times x plus 7. Multiplicity is the power of these factors raised to. So this is x multiplicity 1, x to the 1, x minus 2 to the 1, x plus 7 to the 1. That's right. Move on. Here. If I have a 0 of 1/4, then my factor is x. 0 of positive 1/4, my factor is x minus 1/4. Multiplicity 2 to the second power. If I have the 0 of negative 1, my factor is x plus 1 raised to the third power. X minus 1/4 squared times x plus 1 cubed. Submit. 4 out of 4, or sorry, sorry, not 4 out of 4. All the answers are correct. Let's move on to question 18. All right. Museum charges $4 a person for a guided group of tour from 1 to 10 people, or a fixed $44 fee for a group of 11 or more people. So I'm going to first analyze the group when you have 1 to 10 people. If you have 1 to 10 people, that means n is less than 11. N is not equal to 11. It's the number of people that is greater than 0 and less than 11. Now, you can't have a half person. You can't have 10.5 people take a tour. You can only have 10 people take the tour. So when n is less than 11, that's when you have 1 to 10 people. What's the pricing model when you have 1 to 10 people? $4 a person, where n is the number of people. So if you have $4 times the number of people, and n is the variable standing for the number of people, your formula here is 4n. And the reason for this is that you have n is equal to 1, you have one person coming, your charge is 4 times 1. 5 people coming, n equals 5. 4 times 5, 20 people. It's $20. It's $20. Now, if n is greater than or equal to 11, so as long as you have more than 10, you have a group of 11 or bigger, the output is always $44. Doesn't matter if there's 11 people, 20 people, 30 people, the output is a constant 44. All right, 19. A degree of 8. Leading coefficient 1. The root is x equals 0, so that means the factor is x, the multiplicity is 1. The root is negative 12, the factor is x plus 12, the multiplicity is 2. The root is negative 1, the factor is x plus 1, the multiplicity is 5. Notice 5 plus 2 plus 1 is equal to 8. So this does lead to a degree of 8 because our highest degree terms multiply to each other. We'll create our highest degree term, this polynomial, as x to the 8. So I am going to enter this as x times x plus 12 squared times x plus 1 to the 5th power. Hit submit. Okay, got it right. Clear annotations. Question 20. Let f of x equals x over x minus 3. Evaluate the inverse function of 2. What do I need to do? Find the inverse. X is equal to y over y minus 3. Multiply each side by y minus 3. X times y minus 3 equals y over y minus 3 times y minus 3. The y minus 3's cancel out. X times y minus 3 is xy minus 3x is equal to y. Now I need all my y's on the same side. So I have negative 3x, subtract xy from each side, is equal to y minus xy. I need to get a y by itself, so I need to factor out a y on the right side. This is equal to y times 1 minus x is equal to negative 3x. So y by itself is equal to negative 3x divided by, divide each side by 1 minus x, 1 minus x. So found the inverse. The inverse of the function is f to the negative 1 of x is equal to negative 3x over 1 minus x. And now I need to evaluate f of 2. So that's the inverse of x. I need to find the inverse of 2. That's equal to negative 3 times 2 over 1 minus 2. So that's equal to negative 3 times 2 is negative 6. 1 minus 2 is negative 1. Negative 6 divided by negative 1 is positive 6. So the inverse of if your input into the inverse function is 2, your output is 6. Got that right? That is your polynomials functions video.